Well, welcome to another fascinating edition of videos with Mr. Dex. Today we're going to learn about the law of sines, something that I know you guys have seen before. And the basic setup is if you have a triangle, we're going to call it ABC, and we're going to call the angles capital A, capital B, capital C, and the side opposite each angle is the lowercase letter. Then we can have this set of fractions equal to each other. Pretty straightforward to remember. We're going to quickly go ahead and prove it. So in this picture, if we're going to look at this right triangle on the left side, from that we can get the following statement. Sine of angle A would equal the opposite, which is side H, over the hypotenuse of that triangle, which is side B. Later on I'm going to want to rearrange that and solve for H. So H will equal B times sine of angle A. We can also look at the triangle on the right side, the right triangle on the right side, and from that equation, or from that triangle, I can say that sine of angle B will equal the opposite side, which is H, over the hypotenuse, which in this case is lowercase a. Again, I solve for H, and in this case I would get H equals lowercase a times sine of B. Pause the video here if that does not make sense. From there, I have two equations, both of them equal to H, so I can go ahead and put them equal to each other. So as kind of our second part of this proof, I'm going to say that B times sine of angle A has to equal A times sine of angle B. And I'm going to take these and I'm going to just kind of rearrange some stuff. So if I were to divide this by a little b, I need to also divide this side by a b. These would cancel off. And if I were to divide this side by a little a, I need to divide this by a little a. These cancel off. And lo and behold, we have part of the law of sines. Amazing. And if we were to look at our triangle, if we were to rotate it a little bit, we could add the sine of C over C if we did a little bit of work, but that should be enough just to verify that at least part of this theorem is true. Okay, before we get into actually solving some questions, we're just going to do a little geometry review. I know your favorite part of geometry was when you did your triangle congruence theorems and you had to say that triangle ABC was congruent to triangle DEF by the side angle side congruence theorem, or the side 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 congruence theorem, things like that. We're going to use those same set of three letters in parts of this lesson. So if we were to look at example 1 here, I want to know what situation am I looking at. Is it angle, side, side, and my general rule of thumb for this is that as you look at this and you move around the triangle, it's okay to skip 0 or 1 thing, but if you skip 2 or more, you can't look at the triangle that way. Here's what I mean. If I were to look at the first one and I start at 15, if I'm going to move around the triangle this way until I get to the 10, I'd say, okay, I have a side, but then I have to skip an angle and a side and another angle. I've skipped 3 things before I can say I have another side. So I can't go around that way, therefore I have to go around this way. I have a side, angle, side, skipping nothing. So this situation here is side, angle, side. The next one goes down here, so example 2. Again, I could start with the 30-degree angle, and if I went around this way, around the triangle, I'd have to skip a side and an angle before I got to this side. So I can't go around this way because I'm skipping 2 things. I have to go around this way. I have an angle, skip one side, I can skip one thing, another angle, and then a side. So this situation would be angle, angle, side. Example 3, if you get the idea here, this would be a angle, side, angle. And then example 4, a little bit more difficult. At least we're going to add something to this one. Let's say that I started with the side of 17 here. If I were to go around this way, I would miss an angle and a side before I got to my next angle. So I can't go around this way. I'm going to go around this way, have a side, and missing an angle, and then a side. It's okay, I've only skipped one, and then I have an angle. So this one is going to be side-side angle. And just as a gentle reminder, remember that we always write this particular situation SSA, not the other way around. But the one thing I want to add is that to help us out in this lesson, we're also going to write this as big S, little s, A, to emphasize that as we go around this particular triangle, the big side came first and then the little side as we went around. It's going to help us with a couple of situations. So really for this one, I want this to be your answer. Okay, how do we use the law of sines? First of all, certain situations are going to guarantee that you can use law of sines and that you're going to have one triangle that would fit that description. If you ever have an angle, angle side, or an angle side, angle situation, you're guaranteed you have one triangle. So in this question, we are looking at triangle ABC. We know angle A is 38 degrees, angle B is 46, little a is 9. You could make a picture like this that would get you started. And the first thing, anytime you're involved with either of these two situations, it's going to be really easy to find the third angle. All the angles have to add up to 180, so if you go 180 minus the 38 degrees minus the 46 degrees, you get 96 left over. So right away, I know that angle C is 96. My job now is to solve for little b and little c, the sides. So to start out, if we go back and look at the law of sines on the top of our picture, I could start out by saying I know both of the a's. I know that sine, oops, sorry, I'm going to write it down here instead. I know that sine of 38 over 9 is one fraction I want to use. And if, let's say we're going to solve for little b first, I know that angle B was 46 degrees. And so I want to solve for B. If you have your calculator out, you can go through and just make sure you're in degree mode for this, but we have this nifty thing called cross multiply and divide in this situation. So I'm going to multiply these two things together, divide by the remaining piece, and when I do that, I'm going to solve for B. So cross multiply and divide. When you do that, B is going to end up equaling 10.52. So I would like you to pause right now. Make sure you know how to get the 10.52. If you can't figure it out, write the work down and ask a question in class tomorrow. And once you come back, I'll show you how to solve for side C. Okay, side C is going to be very similar. We're going to again use the same initial fraction. And I'm going to always use that one because I know that those values haven't had to be rounded yet. I could, I suppose, use the fraction involving the b's, but my answer for side B has been rounded. So if I keep doing this, I know that angle C was 96 degrees. Trying to solve for little c again, cross multiply and divide. You should get lowercase c from that is 14.54. And capital C again was 96 degrees. We figured that out earlier. And so in this kind of a question, when they're asking you to solve, your job is to find the missing pieces. We have done that. You've answered your question. Fantastic. We are done with our notes for the video from section 5.